Let's get going. Okay, so paper one, question one, fraction question. So you've got the full numbers there. Okay, so first we need to just break them up again. Okay, and put them into the fraction. So we've got 4 wholes. All right, so we've got 4 whole sets of 3 essentially. Okay, so that's another 12 on top of that. So we've then got 14 over 3 minus, and we've got 2 whole groups of 4 for that second one. So that's 8, 11. All right, so does that make sense? That step I've made, I've taken the whole numbers, their whole sets of the 3s and the whole sets of the 4s. Okay, and then I've added that onto the top. Okay, is everyone comfortable where those numbers come from? Yep. So, thanks. Okay, then we need to make the denominator the same. Okay, so we sort of cross multiply the Cat-Smile technique. Okay, so 4 times 14 is 56 over 12 minus 3 times 11 is 33 over 12. Everyone comfortable sort of making that denominator the same? And then it's a case of just bringing them together. So now the denominator is the same, we can just take away. Okay, so 56 minus 33 is going to give us 23 over 12. Okay, and you will get full marks for that answer, or you could go that one final step and say, well, there's a whole set of 12 in there, so we can take that out. Okay, and then the remainder of that would be 11. Okay, so you would get your 2 marks at that stage. Okay, but that final line, you don't get an extra mark for it, but okay. Lovely way to start. Okay, if I jump forward pretty quickly, give me a wee shout. These should be quite nice. Okay, so these functional notation ones, we've got f bracket and we've got the -3. So the -3 is getting substituted in wherever we've got an x in there. Okay, so remember you can get asked the functional notation questions in 2 different ways. Either you get a final result, you're trying to work out x, or you're getting something to substitute in the place of the x. In this case, we're substituting in the place of the x. Uh, 936. And that is worth 2 marks. Okay, so you get a mark for substituting incorrectly, and you get a mark for the final answer. Yeah, of course. Okay. Everyone comfortable with that? That's up to that. Factorise completely. Okay, so a nice factorisation question. We're looking at CDT. Okay, always just write that out when you see the word factorise, because it gives you the common factor. Okay, some people might jump in and just go, oh, that must be this type. Okay, but we're looking at common factors. We can take 3 out of that. You get x squared minus 4. Okay, and then we do CDT. Again, done the common factor, but we've now got difference of 2 squares. Now we've got our final x plus 2, x minus 2. Okay, and that is it. factorise fully, and that's worth 2 marks. Okay, so you get 1 mark for that step and 1 mark for that step.
So you know about another way is the square bit, first bit, so that a bottom mark.
That's what?
Yeah, so I've done everyone part from X square, so it's in the square foot there.
So that's semi-right.
Right, from the round.
It would just be 3, and then it makes the x plus 3, you would have a 3 again. So that isn't correct, because you've put in another 3 in there in the middle of it. So that's your sort of final line. You see what I mean? Okay, so hence simplify. So we've simplified that top line. All right, we've got the top line there. Now, in these questions, we'll have to factorise the bottom as well, and then we're looking to cancel some stuff out. That first part of that question usually gives you sort of hint of where, of something you're going to cancel out. All right, so we're either going to cancel out the 3, the x plus 2, or the x minus 2, because we're multiplying those 3 things together. Remember, we can't cancel out when it's just purely an addition, it has to be a multiple. So we have to cancel out the 3, or the x plus 2, or the x minus 2. Okay, so usually that's where this question takes you. So we've factorised the top bit, but we want to then factorise the bottom bit, so we've got it in its simplest form. Okay, so get the x squared plus x minus 6 into its simplest form. Okay, we're going to do that by factorising. There's no common factor, it's not a difference of 2 squares, it's a trinomial. Okay, we're going to factorise trinomial. We're going to add and multiply. Adding together to get plus 1, multiply together to get minus 6. Okay, so multiplication fails. Okay, so 1 going to be a plus, 1 going to be a minus, or all the way about. 1 over 6, 2 over 3, and that's it. Okay, so it's going to be positive 3 and a minus 2. Okay, so the bottom line is going to be x minus 2, x plus 3. Okay, so I'm going to take that and put that in a fraction. Okay, so I've simplified the top line of that at the first part of the question. So I've got 3x plus 2 x minus 2. And then the bottom line I've worked out down here. Okay, so I'll put that in the bottom line, x minus 2 x plus 3. Does everyone see where I've got that up from? Yep. All right. And then we're cancelling out. Now the term in the bracket is the whole term. So I'm cancelling out one bracket with another bracket. Okay, or a whole number. Okay, but in this case it's brackets. So I'm cancelling out x minus 2 because there's an x minus 2 in the bottom there. And that's going to give me that is my final answer. Okay, so you get a mark for doing this factorization. Okay, and then you get a mark for cancelling out. And then everything. That's all 3 marks. Comfortable? Yeah, Again, if you need to see anything, if you need to slow down a wee bit, then maybe shout, okay? Or if you need anything explained further, guys online as well, if you need anything explained further, give me a wee shout. Okay, find the equation of the line in terms of T and D. Now the equation of a straight line is y equals mx plus c. M is the gradient. C is where it cuts the x-axis. Sorry, y-axis. I got it. Sorry, cuts y-axis. Now the gradient you're finding okay with that equation. Okay, and you need to know that. You need to know where that comes from. Now we need two coordinates on this. Now it's not immediately obvious where those coordinates are, but we've got 2 points. Okay, we've got our first point at 0 and 100, and we've got our second point at 200, 0. Okay, so if we make that our first point x1, y1, we make that our second point x2, y2. Okay, it's a case of substituting that into the formula. Okay, y2 is 0, y1 100, x2 200. Right, minus 0. So you get minus 100 over 200, which simplifies minus half. Okay. Now that still works if you've taken that's point further right is x1, y1, x2, y2, and the one above. Okay. The negative gradient tells me the steepness of that line, so it's a downward slope, so it's going to be negative, so that puts me in a good position with that. Okay. Now the C part cuts the y-axis. We've got that. It's cutting the y-axis, where x is equal to 0, but it cuts the y-axis at the given point at 100. So our C is just plus 100. Okay. So put that in, you get y equals negative a half. Oops. X plus 100. Okay, but it wants it in terms of T and D. Now T is the label that's been given to the x-axis. Okay, so instead of x, I'm going to write T, and D is the label that's been given to the y-axis. Okay, and if you write negative 0.5, that's worth 3 marks. 1 mark. Your second marks for knowing where it cuts the y-axis. Remember, that's unknown, so that's obviously given to us. Okay, but that was just 2 random coordinates. You would substitute a coordinate in and then rearrange it to find C. Okay, and that would give you your where it cuts the y-axis. Right, we'll practice them as well. Right, I'd say this is a toughie. All right, so ignoring that part on the right for a second. Okay, ignoring that part for a second, that's your question you were given. Now, these do come up plenty of times in the past papers and stuff like that, so you'll see plenty of examples of this, where you get given something like show, or you get given this to sort of substitute in. In this case, we're trying to show sine b equals 5 over 6. Now, what throws people here is the labelling that they use. They've labelled it as b, where the equation in our formula list give it as sine c. Okay, but they've put the letter b there instead. Okay. Now, that is there to try and trick you, try and not stumble on that too much. Essentially, what you're trying to substitute into these, okay, is two sides. Okay, that you'll get given. So two given sides. Okay, and then another angle. So the angle associated with that side is the one opposite it. Okay, so that would be side C in this case. The angle associated with the 9 centimeters would be angle A, so that would be side A. Okay, in this diagram, that would be side C. This angle in there would be associated with this missing side. Okay, that's side B. Okay. Now, this equation, you just need to know two given sides and then the other angle. Okay, not an angle associated with either of those two sides. So in this case, you're given side A and C. Okay, and then we can use that to find sine B. So in this case, instead of A, B, and C, we're essentially saying it's A, C, sine B, because that's the information we've got. We're given A and C. Now these are just random letters that don't need the, and that could have been Q, R, P, Q, and R. All right. What's particularly stumbling in this question is the fact that it's A, B, and C. All right. It would have actually been easier if it was Q, S, T. Okay, because it's a wee bit easier to see and you could put it into that. So don't get thrown by the labels, especially if it's A, B, and C. Two sides plus the other unassociated angle. Okay, so in this case, A and C we've got given, but it's this angle we're interested in. Okay. So we have to show that this whole term is equal to 5 over 6. So let's put in the information that we've got and then start to rearrange to see if we can actually find that out. So we get given the area in the question, which is 30. That doesn't change. Side A is 9. Side C is 8. Okay. Side B. So let's tidy that up and do the multiplication part of it. Okay, remember you can do it in any order. So a half times 8 is 4, so 9 times 4 is 36. Okay, I'm going to spin that round so side B is on the left hand side. Okay. I've not done anything to it, I've not changed side or anything. I've just flipped it round so I've got my sine B on the correct side. Okay, that is a B, not a B. Okay. And then it's that 36 is 36 times the sine B term. So I'm taking 36 over to the other side, and I'm leaving sine B on the left hand side. And then I can simplify that down. Okay, both in the 6 times table. 6 goes into 35 times, 6 goes into 36 6 times, and I have therefore proved that with the information given in that triangle, sine B equals 5 over 6. Those questions, once you've done a couple of them, are actually not too bad. Okay, and you usually get one. Okay, and what you have to remember is you're never going to be asked to determine inverse sine of 5 over 6. And you'll be amazed, someone every year will try and work that out, okay, without a calculator, which is almost impossible. All right. A non-calculator, you will not get asked to do that. Okay, so sine B 5 over 6. Okay, change the subject for the formula to Q. Just about how we organize our equation when we move stuff across. Okay, so P equals PQ over R. Now, the Q is in the top of my fraction there, so that's where I want it to sort of be. That's the best case scenario, I suppose. Okay, but I want it on the left hand side, so I'm going to again just spin that round. So I'm not going to change any side of anything. I'm just going to spin that round so my Q is on the left hand side. That's just the way I prefer writing it. Okay, so I've not changed anything there. Now, I can't move the 3 because that's been divided by that R, okay? So I can't move that before I move the R, so I have to move that R first. Does that make sense? So I'm going to need to leave myself 3Q, P, and it's going to be PR because the R's are dividing the left hand side, it's going to become a multiply on the right hand side. Okay, and then to leave Q on its own, take the 3 over, like that. Okay, so what do you get marks for there? 1 mark for that. Okay, it's changing the subjects go. That's quite a nice one. All right. There's no brackets, there's no roots, there's no nothing like that. Okay, so it's quite a nice one. Anyone unsure about the order I did that there?
And just be a minus, because I thought it was a positive, but I can see it's like, because it's on top of it, it sounds.
Yeah.
So I thought it was. I'll remember that next time.
Daniel, am I right in saying that it doesn't matter if you do PR or RP, it just means the same?
Yeah, it means the same.
Right, thanks.
Sale price of smoothie maker, £48. The sale was 20% off. You get a mark for recognising that that £48 is equal to 80%. Okay. Is to work out the original price. You have to now work out what 100% of that would be. Okay. Now, what I would say is take it down to a multiple that's easy to get back up to 100. So instead of 80%, we want to take that down to 10%. Okay. To get to 10%, we divide it by 8. Okay, so it would be 48 divided by 8. Okay, will give us 10% of that. Okay, so 10% is going to be £6. So 100% is going to be 10 times 10%. It would be £6 times 10. £60 was the original. Okay. You'd also taken it to 20%. So if you divide it by 4, you get £12. You would have got 20%. Then multiply that by 5, get 100%. You get the same answer. Yeah. 3 marks. Over. 3 marks. Okay, simplify 3 root 2 plus root 8 minus 2 root 18. This was done quite badly, actually. If memory serves me correctly. Now, we're trying to get the same root sign. We're trying to get the same number under the root sign. Okay, so we're looking to simplify each of these roots down to its simplest form. Now I can't simplify 3 root 2 any further. Yeah, I can't simplify root 2. I can't take that and make that a smaller number. Alright. That's my clue about where the other ones should be. So I want them all to be in its simplest form. I want them all to be root 2s. And only at that point can I add or subtract the roots together. Okay. But only at that point, when they're all root 2s, are these similar sort of figures, and it allows me to do the add and subtraction. Okay, but I can't add and subtract a root 2 and a root 8. Okay, so I need to simplify each of the terms. So simplifying root 8. Okay, and we're breaking that down into numbers that multiply together to make it, in this case, 2 times 4. Okay, we'll have root 2, root 4. So that simplifies to root 4 would be just 2. Okay, so that would simplify to root 2. Okay, so underneath the root sign, I'm looking to break that number up into a multiple. One of those numbers should give you a whole number when you root it. So when I do root 4, I'm going to get 2. Okay. So I'm going to be left with 2 root 2. That is a good place to be because it gives me a root 2. So simplifying that last term, 2 root 18. I'm ignoring the 2 outside first. Okay, and I'm just going to break up that 18. Okay, 9 times 2. 2, 9, 2, 2, 2 times. So root 9 simplifies down to 3. So 2 times 3 times my root 2. So that'll give me 6 root 2. And then I bring it all back together. Okay, so instead of root 8, I'm going to write 2 root 2. Okay, so bringing it back together, I've got 3 root 2 plus 2 root 2. Okay, instead of my 8. And instead of minus 2 root 18, I've got minus 6 root 2. And now, the number under my root sign is all the same. And only at that point can I add and subtract the terms together. Three plus 2 is 5, minus 6 is minus 1 root 2, okay, or minus root 2. Don't need to write the 1, if you write the 1, that's fine. Minus root 2. The 1's superb. This was indifferent, some of the answers.
What is this?
That's all.
That's what I'm going to do.
So, first, so what it's trying to achieve is getting that in its simplest form. Okay. Now, what it wants you to recognise is the 4 is essentially rooting that number, and the 3 is then doing the power. Okay, so let's put that in. That's not understanding. Now, the first thing to recognise here is this negative sign. Now, when we've got something to the power of a negative, it means it's a 1 over whatever that term is. So, it's actually 1 over 16. Alright, so that's what that negative is telling me. There's a fraction. And now I can rewrite this. Okay, 1 over, and the 4 is the root term. And what I mean by that, if we root that, then we're putting a wee 4 there. Now remember, a standard root, okay, so we've got root of a number, okay, we don't write it, but there should be a wee 2 there. And what that is, the standard way is just whatever 2 numbers, oh sorry, what number multiplies together twice. Okay, that's a normal root. You can get a cubed root. Okay. So what number multiplies together 3 times? Okay, or in this case, I've got what number multiplies together 4 times to give us that. Okay, so that's what the wee 4 tells us. And then put that under there. Now to simplify this, you do the root first. So what, ignoring the power, ignoring that to the power of 3, okay, what number multiplies together with itself 4 times to make 16? Okay. in the non-calculator, it's not going to be a massive number, especially when you're multiplying together 4 times. Okay, so it's not going to be the number 1, because if you multiply number 1 4 times together, it's going to give you 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. So simplifying that to the next step would be 2 to the power 3. Okay. 2 to the power 3, essentially we're just doing 2 times itself 3 times. Okay, so 2 times 2 times 2 is 8. With 1 away. That's your final answer. That's worth 2 marks. What do you mean being only worth 2 marks? Any questions, guys, so far? Plenty. All right. Writing a trinomial in that following form is completing the square. It's just a technique that we need to be aware of. All right, remember that gives us the turning point if we're drawing out something. Okay, but I'm not doing that. We just need to complete the square. Now, x plus minus 2. Yeah. Minus. Okay, so that's a sort of formula there. X minus 5 squared minus 5 minus 25 plus c, which is 12. Again, this is an occasion where don't get thrown by the A and the B here. You can use any letters, you can use P and Q, S, T. Okay, but that's always going to be the formula. So the B that I've written there refers to that second term, and the C I've written there refers to that third term and that first term. Okay. But that doesn't link to that A and that B. All right. That's just 2 random letters they've picked. Again, it's one of those ways to strip you off. Check graphs. Okay. One thing you could do here is draw out a normal cos x graph. All right, you know it's cos x, it's given to you there. All right, you're filling in the gaps in regards to its amplitude and its period. So how big it goes, or small in this case, and how many times it fits into the 360 degrees. So a normal or a standard, whatever you want to call it, cos x graph would equal maximum to minimum to maximum. Your normal milestones are 0, 90, 180, 270, and 360. All right, that's your normal milestones. and your maximum is 1, and your minimum is -1. So that's a normal cos x. So that's your starting point for all this. All right. So what has changed to get to this point? Well, the amplitude is actually smaller. The amplitude is where the maximum min is. So the amplitude is actually 0.5. The amplitude is dictated by whatever number comes in front of that cos x. So A is just 0.5. B tells me how many waves I'm getting in between 0 and 360. One full cos wave goes from a maximum to a minimum to a maximum. So that's 1. Maximum to a minimum to a maximum. It's 2. So my B value is 2. That's it. 2 marks. All right. Some absolutely wild answers for this question. Made me laugh a wee bit. All right, but it's not immediately obvious, but it's similar shapes. All right. What through a lot of people, it doesn't have the word similar in it. All right, it doesn't have to. You just need to recognize similar shapes. Okay. What gives it away is the fact that PQ, line up the top, is parallel with TS. That means all the angles are going to be the same when we take them all into account. That angle and that angle will be the same. That angle and that angle. That angle and that angle. Okay. But that's what it is. Similar shapes. So your scale factor, okay, your multiplying part, comes from your ratio, the big to the small. Okay, so you're going to find a scale factor, okay, a multiplier, scale factor. In this case, you're going from big to small. You're finding, what are you finding? Calculate length TQ from factors. Okay, so you're calculating length TQ, but to do that, you need the length RQ. Okay, so the first thing we're doing is finding length RQ. Okay. To do that, we need to find the scale factor using our two lengths that are similar. Okay, so the bottom one and the top one, and then multiplying it with this 15 to work out that missing bit. Okay, so it's going to go down. Okay, so we're going to do the small over big, so it's going to be 12 over 20. Okay, we want to simplify that down as far as possible, so 6 over 10, 3 over 5. So scale factor will be 3 over 5. Okay, so to find RQ, we're going to do TR multiplied by our scale factor. Okay, so our scale factor multiplied by 15. Okay, you can do it either way. You can multiply 15 by 3 first or divide it by 5. It's easier to divide it by 5. So we'll get 3 times 15 over 5, which is 3 times 3. Okay, which will give us 9. Remember, it's non-calculator. Just need to be able to do that.
I thought I was vexed because it's like directions.
I think what's it, so you're not the only one to do that. Try and do it in respect of doing our vectors. The fact we've done vectors 2 nights previous probably didn't help that. So everyone had it fresh in their memory.
I just don't know where you could kill that from. Like, it's just not clear.
I think just with the given data, I think when you look at trying to calculate TQ, so that's not the final part of that, so we've just worked out RQ. So TQ is equal to TR plus TQ, sorry, RQ. TR is given 50 plus 9, we'll find out. Okay, so it's not far off of vectors because you're doing a path.
That's
Far off.
directions.
Yeah, I can see where the error came from.
It's 4 marks not just.
Is that 4 marks? So 1 mark for essentially one we're looking for. 2 marks for the 3/5, 3 marks for the 9, and then adding it together gets 4 marks. Yeah, that's a big one. 4 marks. When it's similar shapes, a lot of them are going to be more obvious than that. All right. A lot of them will have the word similar in it. You told to recognise that.
I think for those ones, I'm assuming for a question like that, it's a similar setup, just a different shape, like a different one it is. So see for that one, like, see the parallel lines,
Yeah.
I'm assuming they're more than likely give you the numbers for the parallel lines so that you can divide them, to just always divide them and then times it to get that end bit, if you're gonna give you a bit.
Yeah, you're always going to have to find the scale factor.
And then
Yeah.
times it by the. Because I'm not gonna lie, similar to that, no chance in hell I was coming up with any of that.
No.
Yeah, I even took that away to try and look at it and I really was found.
Because we've just done vectors, I can see where they are. A lot of them are going to be more obvious than that in regards to it might be an area or it might be a volume. So like similar size vases or similar size fields or similar size something else, right? So they'll actually use the term. Yeah, that was difficult because it's not making it really obvious. So it's, you get a mark to recognise it's a similar shape.
Yeah, I think I only got a mark because I thought it was a lovely. What's the way what there? So bad. I'm so happy that's actually really good.
Are you close as well?
Is that? I don't know what it was.
See, you've done the scale factors or something, did you? So you were actually, you actually knew you were trying to take it, you just didn't scale factor. You overcomplicated it. Yeah, so long. All right, simultaneous equations. Some people love them, some people hate them. Just get good at them. All right, this is worth 4 marks again. All right, so we're looking for 2 equations. Equation 1, 2 adults plus 3 children equals 1740. So equation 1, 2 adults plus 3 children equal to 17,040 pence. 2, 1 adult, plus 2 children, £10.20. Then we want to do a process of elimination. Okay. To eliminate one from the other, we need to either add or subtract the top and the bottom. Okay, so in this case, we're going to subtract, but we need to get either the A's or the C's to be the same number in front of them. Okay, the same multiplier. All right. Usually we'll target, in fact, we will target the second term. Okay, and then eliminate on that basis. What would probably be easier is if we got the first term similar, but let's stay consistent. So I'm going to multiply the top line, equation 1, by the 2. Okay. So we'll get me 4a plus 6c equals £34.80. Okay. We'll multiply that by 2, and then I'm multiplying that by 3, because that number in front. Okay. By doing that, I'm getting 3a plus 6c. 3 times £10.20 is going to give me £30.60. So far so good. And then to eliminate the second term, I'm going to subtract the bottom from the top. Okay, so it's going to be 4a minus 3a. Give me a. The 6c minus 6c is going to eliminate each other. And I'm going to have £34.80 minus £30.60 to get £4.20. So an adult ticket £4.20. Alright, we don't need to do any more substitution there. Is everyone comfortable with what was happening there in regards to eliminating? Alright, everyone comfortable with where I've gone from equation 1 and 2 to get to this point, and then the subtraction to eliminate. So I'm taking that and I'm substituting this. So I'm substituting a equals 420 into our original equation, so it could be a or b, or sorry, 1 or 2. Okay, so substitute into 1. Okay, and I'll just do that across the page. So 2a plus 3c equals 2a plus 3c equals 1740. Right, 2 times £4.20. £8.40. This one, distance P to Q. Considering it's the last question in the paper, which is usually the trickiest, it's actually not too bad if you know what you're looking for. The distance from P to Q is just how far along the x-axis you're travelling between each. Now we've got a trinomial, and we're getting asked for times on the x-axis where it's cutting the x-axis. We do that by finding the factors. And then we just work out how far, how many units between them. So it's a factorization question. Okay. Factorization. Again, we're doing CDT. There's no common factor there. It's not a difference of two squares, it's a trinomial. So we're adding to get positive 2. We're multiplying to get negative 15. Get a negative, it's going to be positive minus minus positive. That's just a reminder. 1, 15, 3, 5. That's it. Okay, so to get positive 2, it's going to be positive 5 minus 3. So factorize x squared plus 2x minus 15. It's going to give me x minus 3, x plus 5. Okay, now remember, we then take that bracket, do x minus 3 equal to 0, x is equal to 3. We take that bracket, x plus 5 is equal to 0, x is equal to negative 5. So my coordinates of P is negative 5, 0. My coordinates of Q is 3, 0. Okay, so now I've got where P is on the x-axis and where Q is on the x-axis. So the distance between them, okay, well, to get from P to the origin, I'm going 5 units. To get from the origin to Q, I'm going another 3 units. So the distance is 8 units. Does that make sense? So the distance from P to the origin, okay, where the coordinate 0, 0 is 5 units. Distance from Q to the origin is 3 units. Alright, so I'm going back to 0, I'm going back to 0, 5 there, 3 0. Total distance is 8 units. Total distance right.
You know what, I did that at home, I took a picture of this one, and I actually thought I totally murdered it, and that picture what came out in the room. So I don't actually know that happens.
And with these, when we're factorising, always equate that to 0. Formula. Yeah. So we break. percentage question. Right, I'm not going to type it out in the calculator, I'm just going to write up the sort of solutions. Unless I need to. Okay, so you're looking for a multiplier. So this is the percentage over time, how much we're growing over time, how much we're increasing by. So the value of the antique car has been increasing at the rate of 3.62% per annum, okay, for the last 4 years. So we're taking that number, 3.62, and we're creating a multiplier out of it. Okay, so my multiplier will be 1.0362. All right, that's my multiplier. That's what I'm going to multiply my original figure. Okay, over time by. Okay. So for 4 years, my new figure will be new value. Will be my multiplier. Start value multiplied by my multiplier. Power of 4 because it's 4 years. Yeah.
Okay, so you know, yeah, I think we're going to get a lot of time.
What did you add?
No, at the start, we start a lot of time, so in the, I don't know when you plus school, it started instead of 100 plus 3.62.
When you round it up.
And, I don't know, he said,
You crazy.
no,
Did I get them up?
like,
Oh.
don't worry.
But does that make sense?
No, I know you have to do it for something, but just couldn't remember what.
Okay, this was a fun question. All right, so this, it doesn't really matter what angle it's asking for, okay? We just start attacking everything. All right, start labeling up what we know. All right, now A to B is a diameter. Okay, it's going right through the origin. Okay, so remember, you need to be really clear about what's a diameter, what's a chord, blah, blah, blah. Okay, diameter is from one side to the other and it goes through the origin. So A to B is a diameter. That means if I bring a line away from A to another outside edge and away from B to meet that line, the angle it's going to create is a 90-degree angle. Okay, and then I've got one angle, which is a 55, plus the 90 degrees, which means I can find out the other angle of that triangle, because all the angles equal 180. Okay, so we can start just slowly building up these angles. All right, so that angle in there, angle ACB. I don't even know if I need it yet, but I can say that's 90 degrees. Okay, using my rules, and I can say that angle ABC is 180 minus 90 minus 55, which is 90, 40, 45. All right. So I'm just looking at what I've got, and I'm just trying to see if I can figure anything out. Given the angle BAC, find the angle BDC. So find the angle of BDC. I want to find the angle BDC. That's angle in here. Okay, so BCD is isosceles, BD is a tangent. Okay, so what else have we got? Well, we've got the information that BD is a tangent. So BD is this line here, this line on the outside. So that line there is a tangent. Tangent is just a line, a straight line that hits the circle at one point on the outside. Now, if I bring a line from the origin to the tangent, what I create is a 90 degree. So I've got another 90 degree. Okay. But what I also have here is this 35. Okay. So I can find out angle. So what I've done there, OBD, so angle OBD is 90. Okay. But I can do 90 minus 35 to find angle CBD. So angle CBD is 90 minus 35. Give me 55 degrees. Is that angle in there? CBD. That's 55 in there. AB is a diameter, BD is a tangent, triangle BCD. That last bit of information, is everyone sort of following that up to that point? Yeah. So the last bit we're given is triangle BCD is isosceles. The BCD is a triangle, B to C, E, and then we'll close that gap. So that green bit I've got there is a triangle. Now that's isosceles. By isosceles it means that the two bottom angles are the same. Okay, and then we've got two sides at the same length. Okay, so side BD is equal to side CD. Okay. That means the angle CBD is equal to the angle BCD.
You actually wasn't did it in point, so.
Oh, okay. No, what about all of this? The first triangle. And the triangle is equals 180.
But then you know those lines come in, how do you make to know all the other stuff that's recorded and something?
So PCD and CBD equals 55. The two bottom angles equal 110. Okay, so angle CBD plus angle BCD is equal to 110 degrees. Okay, that leaves me angle BDC. Which is 180 minus 110, which is 55 plus 55, so that's angle here, 55, because that green triangle is an isosceles, means that angle there is 55.
So when you see those two lines,
Yeah.
it's usually like a paper that means that those two angles will be the same. So the other scales means that they're close to that.
So yeah, so that isosceles means the two angles at the bottom of the triangle is the same, and it also gives you those two lines to indicate that those are the same length.
The only thing that wasn't obvious to me in that, and then I looked at it, I don't know, I said, right, I had like the right triangles, because I've done other questions like that, and I thought that could be right hand, like a right angle there.
Do you know?
Point it out, and then when I went to mark it, it would be like, that's not a right triangle.
So the only one that sort of threw me for a couple of seconds is this one down here. That line, what that angle creates, should I know that, but you don't, alright. That angle down there comes from this angle to 55 degrees. But just be aware of that. So the only time you know the angle down here is when you've got a line from the origin to the outside edge and a tangent meeting that, which will give you 90 degrees.
So if you see the word tangent, whatever that line is, you know it's going to be making the right
Yeah.
tangent.
So if you've got a tangent, you can take a line from the origin to the tangent, and it will be 90 degrees. Okay. So you need to know the difference between diameter, chord, tangent, all right, and what rules those bring into it. All right, a chord is just a line that goes edge to edge, but doesn't go through the origin or the centre. All right, if it doesn't go through the centre, it's a chord. If it goes through the centre and it goes edge to edge, it's a diameter. And both of those lines have different rules attached to them. Okay. There's always one of those questions comes up, so it's worthwhile just walking through them. All right, taking a bit of time and this clip. Okay, fraction. Right is a single fraction in simplest form. Now the fact that it's got brackets down the bottom there doesn't change anything about how we approach it. We still do the kiss smile when we're adding or subtracting fractions. So we're multiplying that top line by the opposite denominator. Okay, likewise, cross away like that, and then the smile down the bottom, we multiply them both together. But we don't need to break the brackets down the bottom. We just need to go through it step by step. So 3 is multiplied by the x minus 4, and minus 5 times the 7 plus x, all over 7 plus x minus 4. Okay. The top, you need to break the brackets, the bottom you don't. The top, break the brackets, 3x minus 12, minus 35, minus 5x. Okay, and then just tidy, oh, sorry, the bottom stays the same. The bottom you won't be simplifying any further than that. That's in its most simple form. All right, that top line goes to minus 47, minus 2x, minus 2x, minus 47. And that is the final answer.
So I've lost the mark there for I done plus 5x, so then we go on to it there.
This question's a sort of weird one. What it's looking for you to do is just substituting in one of the coordinates to find an unknown value. Yeah, it's a bit odd, but we'll sort of go with it. Okay, so we're substituting in this coordinate, all right, and that will allow us to work out the value for k. Okay, so y equals kx squared minus 2. Okay, and we'll take the coordinate 2 and 14. That's our x term, that's our y term. So we're just substituting that in. That's that. It's what have I done now?
What says that one?
Oh, sorry, I've done that wrong. Well, actually, is that? It's just a substitution question. It's really weird. It's
That might change something.
yeah, a wee bit. Well, it's the application of it. It's actually so. Actually, got it wrong. But yeah, that's the answer. So it's actually it's only 2 marks, and it's really just being able to read stuff off that. So that's what I'm aiming for. I think that's what it's aiming for. So quadratic equation, the one decimal place.
How much was that say?
So first thing here is when we are solving quadratic equations, we need to equate it to 0. So that's 1 over on the right hand side is a problem. We need to have something, a quadratic trinomial on the left hand side equals to 0 on the right hand side. Okay, so we need to rearrange it first to get equal to 0. 3x squared minus 5x minus 6 equals 1. 3x squared minus 5x minus 6 minus 1 equals 0. And just tidy that up. And you don't need to write each of those steps out. I'm just doing that for an example. Okay, now we put it into our quadratic formula and then solve it. Okay, that's given in the formula sheet, that's not part of the question. Okay, I've copied that out of the formula sheet. Putting that into our quadratic equation, getting plus 5 plus or minus root of -5 squared minus 4 times a, which is 3, times -7. Right. All over 2a, which is 2 times 3. Okay, tidy that up and solve it.
First thing on that?
That's here. We're bringing the 1 over from the right hand side into the left hand side. So positive 1 on the right hand side becomes -1 on the left hand side. And then just bring the 1 terms together.
So again, much with the same equation, no?
This. Yes, but you need to get the -7. So you get marks of substituting in A, B, and C into that equation. You don't. You get 1 mark for rearranging. You get a second mark for putting it into that equation. You get a mark for knowing that's 109. Right, so that's stage. And then you get a mark for finding the 2 terms. So you get a mark for finding b squared minus 4ac. Remember that, it's called the discriminant.
I don't know, so what's next is the one sets of time. That's what the.
Yeah, if you've taken -6 into that, you won't get a mark. You need to equate it to 0. Okay, so the first part of this question A is find coordinates of B. Okay, so find the coordinates of this point here, the bottom right of that cube. Okay, so the 3D graph throws in another axis. So we're used to our 2D with our X and Y's. The 3D throws in this other Z axis that allows us to map out 3D shapes. All right, so this is one part of our vectors. Okay, so point A has the coordinate of our X, which is our horizontal axis there, being -6. From our origin along the X-axis, we've gone to -6. Our middle number is our Y value. Now what is a wee bit confusing in these graphs is the Y value sort of tilted and is flat as well. Okay, the Z value gives you your height. So the Y value is on its side a wee bit. Now the Y value here is 0. Okay, because you've not gone up or down the Y-axis at all. Okay, you've stayed on 0, if you can imagine that. Okay, and then the final number is your Z. Okay, so your X, Y, Z. The Z is your height. Okay, so you've gone up 8, it's giving you height of 8 units. Okay, so the cuboid has a base measuring 6 units, which is your X. Okay, and a height of 8, which is your Z. That face, which A sits on, is 0 and the Y, it's sitting on the Y-axis. Okay, does everyone understand where those numbers are coming from? X, Y, and Z. Okay, so thinking about that, now we look at B. Okay, now again, we're looking for a coordinate. So we're looking for the value of X, the value of Y, the value of Z on this. Now B is the bottom face, and it's the one closest to us essentially. So looking at it from an X perspective, if from our origin, we've not moved to the left or right on the X-axis, we've stayed in the centre, we've stayed on that middle line. So the X value is going to be 0. I'm going to skip Y for a second, I'm going to go to the Z value. Again, the origin is where our start point is. So our origin is the coordinate 0, 0, 0. Okay, where we haven't moved in the X, Y, or Z. So we've not moved in X, okay. We've also not, for B, we're sitting on the bottom face, so we've not got any height. So the Z value is also 0. But what we have done for B is we've moved on that Y-axis. Now, by what distance have we moved? Well, we've come closer to us, okay? It's not immediately obvious, you need to read the question. We've come closer by 2 units. So the 6 units is the X-axis. The height is on the z-axis, so the 2 units must be related to the y-axis. Now we've come closer to us, okay, so if we're moving from the origin closer to us, we're going to say that's negative y, and moving that direction would be positive. So we've come closer to us, so we're negative, so we're negative 2. All right. Letting that sink in, does that make sense where those numbers are coming from? Let's have a-
It's just that does. There's too many, actually, it's just.
But once you've done one, they're not going to change the format. They might word it a wee bit differently, but they're not going to change the format. It's always going to be like a cuboid or a cube of some sort.
That's it.
So asking for position in 3D shapes. So in 3D, you need to be able to label each of these columns. This is one part of vectors, the 3D shape aspect of it. Second part of that question, it asks to find the components of vector AB. Vector AB is essentially connecting points A and B. Okay, so we drew a straight line inside that cuboid that connected A and B. All right, the components tell me about that movement. So it tells me how far I've moved on the x-axis, tells me how far I've moved on the y-axis, and it tells me how far I've moved on the z-axis. Okay, to find that, I need to take what I found in part A and take away the first coordinate. All right, so component AB, we write it like that, 3 minus 8, where I'm ending up and where I start. So I'm taking away my start from my finish. Okay, so component AB is, and I just write it in the vertical. Okay, so 0 minus 6 is just positive 6. Okay, minus 2 minus 0 is minus 2. 0 minus 8 is minus 8. That describes how I get from A to B. I've moved along 6 on the x-axis, I've moved towards me 2 on the y-axis, and I've moved down 8 on the z-axis.
So you always take the away from the end.
Yeah. So just run like that. So your finish minus your start, essentially. Give me a few. Okay, so the mean value is just all those values added together, divided by 7. So the mean I'm getting is 3.2, and it's in millimeters. Okay, so x minus x bar is just my value minus my mean. So 2.8 minus 3.2, 5.6 minus 3.2, all the way down. Okay, my last column, and this is just a way to organize it, is x minus x bar squared. All right, so whatever value I'm getting in this column, I'm squaring it in this column. All right, now it's always going to be a positive value. So 0.16, 5.76, 0.81, 38.44, 10.24, 7.29, 1.16. All right, and the sum of all those added together. Okay, so that wee symbol there, it looks like a crazy capital E. All right, that just means sum of, that just means adding all those numbers together is going to give me the value of 64.66. Okay, now that value we use in this formula. We just substitute that right into that formula. That formula is given in the formula sheet. All right, so we're just taking that (64.66) and putting it right in there. All right, that's all we're doing there. N minus 1, n is just the number that we're given. So 1, 2, 3, 4, 5, 6, 7. 7 minus 1. Okay, and then we're solving that, and that is our standard deviation. Our standard deviation shows us how variable those figures are. Okay, so standard deviation tells us about how consistent the numbers are. All right, what we're expecting in regards to the differences from one number to the next. Okay, so it's calculated standard deviation, the one decimal place is 3.3. Okay, it's just following through that process. That is worth 4 marks. Valid comparison. We're comparing that standard deviation of 3.3, okay, with the standard deviation of 2.3. Okay, so the first thing we need to compare is standard deviation. The second thing we need to compare is the mean of 3.2 and the mean of 3.2. Okay, so the mean values are the same. So on average, the mean, on average, the rainfall is the same. All right, the average is the mean. What are the differences in regards to the mean? Where John lives, the rainfall is more consistent. Because the standard deviation is lower. So the lower the standard deviation, the more consistent the numbers are. All right. The higher, so the first area where Paul lives, the rainfall is more variable because the standard deviation is higher. Okay, so the mean rainfall, the average rainfall we get is the same, but it varies more where Paul lives. Some days you get that, some days you get a little. Okay, standard deviation, it's worth 6 marks all in. Alright, standard deviation questions over 10% of that paper. Paper 2, the 50 and the 40. Alright, so you're over 10% with just that question. Okay, solving the equation. This is using our cast diagram. Okay, we recognise this, okay, with the format that it's laid out on. Okay, we're getting a trig variable, I suppose, and then it's between 0 and 360. So we're looking for a result in between 0 and 360. Okay, so we're looking for 2 answers. So remember, we're thinking about the trig graphs. So we're rearranging that just to leave tan on the left hand side. So 4 tan x plus 3 equals 0. 4 tan x equals -3. Tan x is equal to -3 over 4. Now at this stage we pause and we look at whether it's a positive or a negative here. It's a negative. What that tells us is where the answers are going to be, what quadrants the answers are going to be. So tan, the graph tan is negative between 90 and 180 and 270 and 360. Okay, so remember 0, 90, 180, 270, and then all the way to 360. Okay, so that just tells us where the answer is going to be. So when we put it in our calculator, okay, we're going to get an answer out, okay, for value of x. So we now rearrange this to find the value of x by taking tan over to the other side. Okay, putting that in. Okay, so now we don't need that negative side. Okay, we're looking for our answer inverse tan of 3 over 4 or 0.75. So we're just putting that in a calculator. So we're getting an answer of 143. Point 13. Getting an answer of second tan. 36.86.
I did -1 in the tan. Sure. Oh, it's
Yes,
negative.
yeah. Okay. Now again, that's not where we leave that. Okay. Okay. Okay, so we're taking that into quadrant S. We're taking that into quadrant C. Find the value in quadrant S, we're doing 180 minus 36.87. You get 143.13. Okay. Quadrant C, we're doing 360 minus 36.87. get those two answers. And that's our two answers. Okay, so there's a few things you need to be aware of, you need to be comfortable with going forward. The first bit is what you do when this bit's negative or positive, what that actually means. And how you then take that into this cast diagram and how you pick your quadrants. Alright? You're then finding the X, and then what do we do with that X? How do we find whatever quadrant we're going to be in? Any questions on the calculator so far?
I think that one's a pretty tough one. Get your head around it. I would love it's just because I've not done that enough. But
Again,
I don't know how you to do it. For obviously I get like the way from the graph and then it goes round a certain way. Like that, I feel like that's, I'm never going to remember that. Like it's like 90, 182, 17.
again, it's one of those things that if you do a couple,
Just
it
get
starts to just stick in your mind. And they're all the same format. Alright, so they won't deviate away from that. They might change between cos, sin and tan. Don't worry about that, it's just something you're putting in the calculator as long as you're hitting the button on the calculator. And then being aware at this stage what that actually means. Okay, so negative sine would be tan inverse. Negative cos would be sin and tan. Or if it's positive, what you would do with that. Alright, so there's not many places that can take that type of thing. We're sort of running out of time.